What we're going to look at in the next few videos are special situations in related rates. I don't want to show you everything at once because that might confuse you. So we're just going to do different examples every day. Today's example involves cones. Here's our question. A water tank is built in the shape of a cone. The cone has a height of 5 meters and a radius of 6. Water is being poured into the tank at a rate of 1.6 meters cubed per minute. At what rate is the water level rising when the water is 2 meters deep? So let's start with a cone. Here's our cone. The cone has a height of 5 meters, radius of 6. The water being poured into the tank also has a radius and a height. 1.6 meters cubed represents volume, so we'll probably start with the equation for volume of a cone. The volume of a cone is 1/3 pi r squared h. Now, here's what's new today. Count your variables. 1, 2, 3. Count your rates. 1.6 meters cubed per minute is a rate, and they're asking for the rate of the water level rising. 3 variables, 2 rates. We're in trouble. If we try and solve the equation, we'll be missing some information. If you have 3 variables, you need 3 rates in order to be able to solve anything. So before we continue, we need to get rid of a variable. Here's how we're going to do it. The red triangle is similar to the blue triangle. What they have in common, they both have a right angle at the top, and they share this angle at the bottom. When triangles share 2 angles, it means the third angle is also the same. So the red triangle is just a bigger version of the blue one. That means that the sides are in the same ratio. The ratio of the radius to height on the red triangle is the same as the radius to height on the blue triangle. So the radius of 6 divided by the height of 5, same as the radius of r divided by the height of h. Again, the variables that were given and the rates. We're talking about the change in volume, so we want to keep v. We're talking about the change in water level, which is height. We want to keep h. That means we need to eliminate r. So over here, we're going to get r by itself. To do that, let's multiply both sides of the equation by h. 6h over 5 is what r will equal. We'll then put the 6h over 5 in immediately for r. This is a little bit nasty, so we're going to take the 6, square it, the h, square it, the 5, and square it. So we're not taking a derivative yet, we're just cleaning up the equation. 6 squared, 36. 5 squared, 25 times 3. H squared times h. Now that we have a cleaner equation, we're going to take the derivative of both sides with respect to time. Change in v with respect to t, take it with respect to v first, and then multiply by the change in v with respect to t. The pi h cubed, we'll take that with respect to h first, that will become 3 pi h squared times your number, and then multiplied by dh dt. So multiplying by 3 times 36 is 108, 75 hangs around, pi h cubed becomes pi h squared, and there's our dh dt. What is it we're looking for? Rate. Rate always involves the d's. Water level rising, that would be h, so we're looking for dh dt. So we'll divide dv dt by everything else on the right-hand side of the equation. Now, let's fill in what we know. dv dt, change in volume, 1.6, being poured into the tank, so it's positive. Height is 2, so we'll put in the 1.6 and the 2. And then this 75 in the denominator is really quite annoying. We don't like fractions over fractions, so what if we multiplied top and bottom by 75? That would get rid of the 75 here and put it here instead. So let's just recap where things came from. Change in volume over time was 1.6. There's your 1.6. H was 2. There's our 2, and we're squaring it. The 108 pi stays in the denominator. The 75, we multiplied top and bottom of the fraction by 75, put the 75 in the top, and eliminated it from the bottom. At this point, just multiply things out and clean it up. You should end up with 5 over 18 pi. Now for the units. dr, change in radius. We're measuring distance in meters, so that would be meters. Time we're measuring in minutes. So the water is rising at 5 over 18 meters per minute. So rising, we know that because it's increasing, and so it would be rising and not falling. It's getting bigger and not smaller. But let's just do a recap of what happened and when we know to look out for this. Count your variables. 1, 2, 3. Count your rates. 1, 2. If they don't match, we need to eliminate a variable. How do you know which one to eliminate? Talks about change in volume, keep V. Talks about change in height, keep H. Let's get rid of R. How we got rid of R? We had two similar triangles. We set up a ratio, radius to height in the red one, radius to height in the blue one. We wanted to get rid of R, so we get R by itself and multiplying by H. Put this in for R, clean it up, then take a derivative. Find out what you're looking for, get it completely by itself, and then fill in the missing information. Make sure you answer your question in words. Your job today on page 6, we're moving on to related rates number 2. And don't panic, not all the questions look like this. Some of them are exactly what you did yesterday. So if you have 3 variables and 3 rates, take a derivative. 2 variables, 2 rates, take a derivative. The only time you have to do this is when you don't have enough rates to match your variables. If you have any questions, let me know.